Hello viewers, welcome back to another section of my YouTube tutorials. In this video, I'm going to take you through Gaussian elimination principles in numerical analysis. So as part of numerical analysis, it deals with simplifications of system of equations. If you are being given systems of equations to solve, some systems of equation can be solved using the Gaussian elimination. So in numerical analysis, for us to be breaking down systems of equations, the first method we deal with is the Gaussian elimination. It's the basic and the first step you can ever take when you are handling systems of equations. So under Gaussian elimination, we are going to consider two things. The first one is the forward elimination of unknowns. Then the second one is the back substitution. Forward elimination of unknowns. Then you have the back substitution. So when we say forward elimination of unknowns, what do I mean? So when I give you a matrix, so application of matrix, if you have a matrix, you realize that your first entry, considering 3 by 3 matrix, will be what? An unknown 1 1, where this first one means row, then this one means what? Column. Our second entry, row and column wise, will be a 2 1, right? So this is what? Row 2 column 1. Then finally we have a 3 1, that is row 3 column 1. Here we are going to have a 1 2, then a1 3. Here will be a2 2, a2 3, and it follows like that: a3 2, a3 3. So take note, when you are doing this coefficient that we have here, they are the coefficients of the systems of equations which you are going to be solving. So whenever you see A11 in matrix, it means that row 1 column 1 unknown, row 1 column 1 coefficient. So now let's see how the forward elimination of unknowns work, the whole principle of Gaussian elimination. So our aim of the forward elimination of unknowns is to end up with a triangular matrix, which is an upper triangular matrix. So we want the entries here. So you maintain the A11, then make sure that we eliminate this one, we eliminate this one, then as well as we eliminate this one, so that we get A22 here, we get our A23 here, then we get our A33 here, then our A12 is also here, A13 is also here. So you know that once we express this matrix into this form, we can easily find the value of what? Our 833, meaning that you have eliminated this, you've eliminated that, you've eliminated that. And once we get a value for 833, we can simply get the value for the others, because when I get a constant, when I get a, so you see for this side, you are going to get x1, maybe x1, x2, x3. So we know that when you have this coefficient here and this constant here, so we can find the value of what? X3 from this side. We can then use x3 value to get a value of x2, then to get a value of x1. So all I'm trying to say is, when you have any matrix and you are using the forward elimination of unknowns, our goal is to express it into a diagonal, into an upper triangular matrix, so that some of the entries will be eliminated, that is the unknowns. So for the first row, we maintain all the unknowns, the second we remove one, and the third we take out of what? two unknowns. Then we come back with what? Back substitution. So this was an illustration. So how do we eliminate the A11, A21 as I showed you? So let's see some short scenario here how we can eliminate that. If you have this and I want to eliminate this one, so check, we have to eliminate this, eliminate that, and eliminate this. So how do we do that? Always divide your first entry, that is the A11, divide it by A11. You divide it by A11, then after you multiply it by this one. So first divide this whole row 1 by this constant here, then after you multiply it by this, by what? A21. So when you do this A11 will cancel out and you get getting what? A21. When you do same for this one, we can also divide this one by A11, then you multiply by what? A21. You do same for this, divided by A11, then you multiply by A21. So in effect, you realize that the first entry will be A21, then the second one too will be what? This one divided by this times A21. So maybe A12 A12 all over A11 multiplying A21. So these entries that we are getting, our goal of getting these entries is to subtract it from the second row so that we eliminate the A21 here, because when I multiply this by the A21 and divide it by the A11, the entry will be A21. So when I subtract this from my row 2, here will be 0, but this place, when I subtract this one from this, there will be a constant here as well as this. So the forward elimination, we make sure that our first entries are our focus. Only make sure that after modifying this first row, our first entry and this first entry will be the same. The others, we don't consider them. So once we get the same thing, we just subtract to eliminate this constant here. Now, how do we eliminate the A31? So when we are doing the elimination, we make sure we eliminate only the first column first, then we come back to the second column. To eliminate our second one, this 0, that is the A31, what you are going to do is you are going to take the A11, you divide it by A11 itself, then you multiply it by what? A31. So when you do this simple arithmetic here, you will end up getting what? A31. So meaning that this A31, when you subtract it from this, it is going to eliminate this and it will give us 0. So that is how you go by the forward elimination of unknowns. Then how do you think you are going to get this? So after eliminating after your first elimination, you are going to get this. You get your A11, you get your A12, then you get your A13. Then here will be 0, here will be 0. Then you get your A22 here. You get your A32, your A23, and your A33. So this is after the first elimination of what? Unknowns. Then we come to tackle what? This place. Then we make here 0 so that this one we can easily find a value for what? The unknown here. So to do this one too, we tackle this here so that we divide what? A22 by what? A22. You divide all this row by what? This constant here. Then you multiply it by what? A32, so that we get A32, A32. Then you subtract it from this to make this side what? 0. So this was a simple scenario that I was showing you. Let's go into solving a problem so you understand what I'm saying very well. So let's see. So I have this problem here. 20x1 plus 15x2 plus 10x3 is equal to 45. Then I have negative 3x1 so negative 3x1 minus 2.249 x2 plus 7x3 is equal to 1.751. And our last equation is 5x1 plus x2 plus 3x3 is equal to 9. So it's equal to 9. So we have our first equation here, our second equation, then our third. So we have to solve this using the Gaussian elimination. Gaussian elimination. That is the question. So numerical analysis, we'll be given a problem, a system of equations, then we asked to solve this with the Gaussian elimination. So how do we do that? Your first step, you have to write it into the matrix form. So you write it into the matrix form. You leave the equation to matrix. So how do you solve it into convert it to the matrix form? You need your coefficient matrix. And since it is 3 equations, you are going to get 3 by 3 matrix, right? So our coefficient, first one is going to be 20. You write it 20. The second one here is 15. The third one is what? 10. Then we come down negative 3. Negative 2.249. Then we come to 7. Then here we have 5. We have 1 because here is only x2. Here we have 3. So all this multiplying x1, x2, then x3 should be equal to, then you bring your solutions to on the other side. So it should be equal to 45 1.751 then 9. That is all. So this is our first step. We've represented this whole system of equations into the matrix form, right? So once we get this, we simply move to the second part, which is the forward elimination of unknowns. That is forward elimination of unknowns. let me make it forward elimination, then we move on. So that's the part 2 of how to use the Gaussian elimination. Sure. So once you reach this level, how do we convert this one to our upper triangular matrix? And I showed you using the A11, A21, then the A21, A31, and the rest. So now we have actual numbers here. Let's see how we are going to convert them. So first of all, I said you are going to divide the first row by what? The first entry. Our focus is for the first entry. Then after we multiply it by what? The first entry of the second row. So we are going to get 20 over 20 times negative 3, and obviously this will give us what? Negative 3. So our aim is to modify the first row so that we get something similar to the second row. Then we subtract it from the second row to eliminate this. So you can see that our first entry will automatically be the same as this. Now what will the second entry be? So you can see that we are making negative 3 over 20, because when you divide a number by 20 and multiply it by this, I can make it negative 3 over 20. Then the next one is the 15. I have to multiply it by the 15. So if I'm multiplying it by the 15, what am I getting? So negative 3 on 20 times 15. Negative 3 on 20 times 15. And that is negative 2.25. So I'll get negative 2.25. Then for the third part, I'm going to get this one multiplying by what? 10. So I can make it negative 3 over 20 by 10. So when I multiply this by 10, what am I getting to? So I'll multiply this by 10. Then I'll be getting negative 1.5. So negative 1.5. So now I have negative 3, negative 2.25, negative 1.5. This is the modification of the first row entries. So let's go and do our elimination. Our elimination simply means that you will subtract these values from the second row entries. So you are going to get something like, so you write all the original second row entries, negative 3. So you get the negative 3, then you have our negative 2.249. That is the original entries. This one. Then we bring your 7 to, then we bring our minus sign because you are going to subtract these ones from it. So I'll subtract my first negative 3 from it. Then the next one is negative 2.25. Negative 2.25. Then I'll get negative 1.15 as well. Negative 1.15. So once I have this, then I do my subtraction so that I get some eliminated. So here will be 0. So negative 2.249 minus negative 2.249 minus, so it's going to be plus, minus 2.25. So plus 2.25 is going to give us 0.001. Then this one I'm going to get 7 minus this, I'll get 8.5. So this is my new row 2 entries because I have eliminated my negative 3. So right now we've been able to eliminate this negative 3 here, then we are getting our new row 2 entries. So now the next thing is to also come down here to eliminate the 5. To eliminate the 5, we divide the first row. We are going to modify the first row to do our first elimination of this side. So divided by 20 times 5, right? So 20, 15, 10 once again. So you have our 20 over 20 times 5. So let me show you back again. So this is it. So we divide this 20 by 20, then we multiply by this 5, so that we modify this and you get the first entry of this modification to be 5, then you subtract it from this side to get this one eliminated. So this one too, we are going to get the first one to be 5. Then now let's see, this one too, I'll get 20. So here it will be 15 over 20 times 5 here. So always just take this one over the first entry. So the next one will be, so I'm going to get 5 on 20 times 15. 5 on 20 times 15. And what would that be? So 5 on 20 times 15. So 5 on 20 times 15. I'm going to get 3.75. So 3.75. Then finally 5 on 20 times 5 on 20 times what, the 10 here. Then that will be our last modification. So 5 on 20 times 10, and what will I get? 2.5. So that's going to give me 2.5. So 2.5. So once I get this 2.5, I've got my new entries. So now I'm going to write my last row 513. So I'll put my 513. So 5 1 then 3, then I subtract it, this one, the new modification. So 5, then finally 3.75, then I'll have 2.5. So when I subtract, this one will give me 0. This 1 minus this should give me negative 2.75. 3 minus this should give me negative 0.5. So this is my new row 3 entries. My new row 3 entries. So once I have my new row 3 entries, I'll rewrite my equation once again after the first elimination. So I have my first entries 20, 15, 10. But take note, as you multiply, you make sure that we deal with this side also. So after modifying here, we can also continue the simplification here for it to reflect here. So here we multiply 20 over 20 times negative 3. So that was the initial one. So for the initial one, to modify this side, we are also going to divide this side by 20. So we have 45 on 20, 45 on 20, then you multiply that one by the negative 3. So let me show you, let me rewrite this, then also we do that one too. So you have 20, 15, 10 here. So this is our new matrix, coefficient matrix. So 20, 15, then 10. Then the next thing you're going to do is you write our new row 2 entries. The new row 2 entries, as I showed you, I have my 0.001, then 8.5. So 0.001, then 8.5. Then our new row 3 will come 0, negative 2.75. Then you have our negative 0.5. So once I have this, I'll multiply it by my variables x1, x2, x3, my x2, then my x3. So this is the other side. Now let's go to the solution side. The solution side also needs to be affected by our simplification. So this is what you're going to do. So as I was saying, to modify this side, the first one, you are going to multiply this by what? The negative 3 we did here, then you divide it by the 20 as we were doing. So 45 out of 20 times negative 3, what would that be? 45 over 20 times negative 3, and that will give us negative 6.75. Negative 6.75. So this negative 6.75, you realize we subtracted our modification from the row 2. So I'm going to subtract it from this one to get our new entry. So I'm going to get that part to be what? 1.751 plus, because it's going to be minus 6.75. So plus 6.75, and I'm getting 8.501. 8.501. So that is going to be our new row 2 solution entry. 8.501. So let me write it. So this will be equal to, so the first one is 45, then our second entry after modification is going to be 8.501, then our final one, which is this side, we multiply the 45 by what? By 5, then we divided it by the 20 again. So as we did for the coefficient matrix, will be same for this side too. So here is what? 9, right? So you divide this side by 20. So 45 over 20, then you multiply it by what? 5. So 45 over 20, then by 5, and that is giving us 11.25. So you put your 11.25 down, So 11.25, you put it down. Then, so that is 11.25, right? 11.25. So once you have 11.25, you know you subtracted that from the root 3 to eliminate this 5. So you subtract it from what? 9. So 9 minus 11.25. And that is the negative 2.25. Negative 2.25. So let's see. Negative 2.25. Negative 2.25. So that is it. So this is where we have reached with our elimination. So at this point, you have made here 0, made here 0. The next thing is to make what? Display 0, right? So to make this place 0, what did I say? You are going to divide this here by itself, then you multiply it by the value here, so that we get the same value, then you subtract. So see, you have 0.001. So 0.001 all over itself, 0.001 times negative 2.75. So when you get this, you are going to surely get the same value, that is the negative 2.75 for the modification one. Then you do that same thing for this side. So we divide what? Negative 8.5 by 0.001, not by itself. So 8.5 by what? 0.001. Then you multiply that 2 by what? Negative 2.75, and that will give us what? So 8.5 over 0.001, then multiply it by negative 2.75. That will give us 23375, and it's a negative number. Then finally we divide. Then after we come to this side, so for this side too, we are going to divide this 8.501 all over this one once again. That is, you are dividing the whole row and it's cut across to this side. 0.001, and that is going to give us what? So when you divide, you multiply by negative 2.75. Take note. So let me divide this first. 8.501 over 0.001, 10 times negative 2.75. That is negative. So here, this 1 2 is here times this number is here. So we are going to get negative 23377.75. So we come back, then we do our subtraction. So to do the subtraction, what you have got, you subtract it from what? From this side, because we made the first entry look like on this one, negative 2.75. So I'm going to have my entries 0, negative 2, 0.75. Then I have negative 0.5 minus, the first one is negative, so here is 0, negative 2.75. Then finally this place is what, the second entry is what, negative 2, 3, 3, 7, 5. Right, then this side too will come. So the last side was, for the solution side, was negative 2.25. So negative 2.25. Then after modification I have this number here, negative 2, 3, 3, 7, 7.75. When I subtract, it will be 0. I'll get here to be 0. Then now here will give me negative 0.5 plus 2, 3, 3, 7, 5, right? So I'm going to get negative this plus this, because it will add, and here I'll get 2, 3, 3, 7, 4.5. Then when I come to this side too, I'm going to subtract likewise. So this will be this plus this. So I'm going to get negative 2.25 plus 23377.75. So I'm going to get 23375.5. Right, so this is my new rotary entry. Take note. So now I'm going to rewrite my entries once again. So the 2015-10 still remains, 0.001.8.5 still remains. So 2015-10, I'll open my bracket. 2015-10, then I have 0, then the second part is going to be 0.001. Let me bring that one here. Then the third part was 8.5, right? Yes, you write that one too. Then here is 8.501. So 8.5 is going to be here. Then this side will be 0. That's the new entries. 0, 2, 3, 3, 7, 4.5. Then we close it. We have x1, x2, x3. Then this should be equal to, so this side I'm going to get the new entries once again. It's 8.501, and the last entry is going to be the new one. So 45 8.501. Then the last one will be this number 23375.5. So now we can finally say that we are done with our forward elimination, because this has become an upper triangular matrix. This is 0, this is 0, this is 0. So I hope you've understood how to convert it from the 3 by 3 to the upper triangular matrix. And at this point you can easily find your value for x3, because 2, and this is what we call the back substitution. So back substitution. So now we are going to do that. So see, we have to find the value for x2 before we do the back substitution. So 2 3 3 7 4.5 times x3 should give us what? This side. 2 3 3 7 5.5. So meaning that we can find x3 from this side, right? So my x3 is simply equal to this number all over this number 2 3 3 7 4.5. So we do this simple thing, 23375.5 over 23374.5, and we are getting 1. That is 1. So it's actually 1.000. So 1.0004. That's approximately 1. So this is the value we've got. So it's 1. So once you get this 1, the next thing to do this is to come back. That is the back substitution. You put this x3 into this one so that you find out the x2 as well as the x1. So let's do that quickly. So the second equation, we are going to get this 0. So we are going to get 0.001 times what? X2. Then you add that one to this number times x3. That is 2 3 3 7 4.5, and that will multiply by x3, and x3 is now what? 1, and it should give us what? So see, it is, oh sorry, so let me cancel this. We are rather doing this place, so see this row. So it's 0.001 x2 plus 8.5 x3, and x3 is now 1. It should be equal to 8.501, right? It should be equal to 8.501. So now how do you find our x2? our x2 is simply equal to, you maintain this, then you send this one. So 8.501, then you subtract. So you're going to have, so our zeros then come. So this minus 8.5, because you are bringing another one here. So our 8.5, then everything over 0.001. So what are we going to get? So 8.501 minus 8.5 all over 0.001, and that is 1. So the answer is what? 1. Then finally, you move to the first equation, you make all substitutions, and this is what we call the back substitution. So 20, 15, 10, then 45. So you are going to get 20x1 plus 15x2 is 1. So 15, 1, then plus 20, 15, 10, 10 multiplying out 1, and all should be equal to 45. Is equal to 45. So here we get 15 plus 10, 25. When I subtract, I'm going to get what? 20x1 to be equal to 20x1 to be equal to 45 minus 25, that is 20. And you realize that my x1 is what? My x1 is simply equal to 1. So therefore my solution is simple. I'm going to get x1, x2, then x3, all being equal to what? 1, 1, 1. Thank you for joining this video. Please like, you subscribe, and you share. Don't forget to turn on the notification button, as I'll be posting a lot of tutorial videos on this channel. Thank you.